Hello. Okay, today we're going to do the hyperbola. Hyperbola. So what is a hyperbola or hyperbola? Well, it's this. It's got two parts. It's kind of like an ellipse, and someone turned it inside out. Imagine I took an egg and cracked it open and turned it inside out. Where could you see one? Here's one right here. And so here's a lamp. When light hits a wall, it creates this hyperbola shape. Looks like a parabola, but it's actually straight, bends, and kind of goes straight. And there's a top and bottom. Of course, if I cover up the bottom, you don't have the top. So hyperbolas, I show you some pictures of them. Hyperbolas could open sideways. And notice what they have. They got the vertex again. The vertex is right here. This is called the transverse axis, and the focus is out here. The focus is always inside the curve. This is where, if you look at my pictures, where the energy focuses. But it could also go, it could be kind of narrow, but sometimes they go up and down. And there's a little difference in the equation. Let's look at the hyperbola equation. Hyperbola. Okay, so remember we had our circle. And instead of having r squared, if you put a 1 over there, you got a squared and b squared. You have the ellipse, the x radius, the y radius. What's the difference now? Wait, it's the same equation. What's different? What's different? What's different? This. Instead of plus, it's minus. It's inside out. But there's a second form of it, or this. Wait a minute. They put the y over here and the x over here. This matters because with minus, the order of subtracting matters. You know, like 6 minus 5 is not the same as 5 minus 6. What is the difference? Why is there 2? Why is there some with x first and y first? Well, here's very, very important. If x is first, the vertices are going to be on the x directions, and it's going to go out in the x directions. You're going to have curves going in the x directions. If y is first, it's going to be an up and down. Y, it's going to go in the y directions. Okay, so that's kind of important to remember. How do I graph this funny shape? Okay, so there's a trick. And the trick is to make a box. Let's see how this works. Okay, I'm going to do my first one on graph paper. I didn't put anything next to x and y, so it must be a 0, 0. There's no movement around. So you're like at 0, 0. That part's not actually existing on the graph, just gives you a reference point. And just like before, pretend you're doing an ellipse. But remember, because of the minus, this is a hyperbola. They're used to locate earthquakes. They're used for navigation. Yeah, I show you some videos and some pictures that you can see. So what do? Here's the x's radius. Once again, this is a or b, doesn't matter. The book makes you think it matters, doesn't matter. A squared is 4, so a is plus or minus 2. Over here, b squared is 25, so b is plus or minus 5. So the x direction we're going to go to, 1, 2, put a dot, dot, dot. Okay, b, y direction is 5. 1, 2, 3, 4, 5. And you go, looks like you're drawing an ellipse. I am. Here's what you're going to do. If this were a plus, you would draw an ellipse, wouldn't you? But it's not. So here's what you do. Do not draw an ellipse. Draw a box. A box? Yes. Draw a box. Now the box is supposed to be invisible. Draw a box like this. Now normally we do, you're not supposed to see the box, but I'm going to draw the box. Because you need the box. Because the box will help you draw the hyperbola. That's right. The box will help you draw the hyperbola. Okay. Okay, so I drew the box. Okay, what do you do now? You use a ruler, and you're going to draw 2 asymptotes. In other words, invisible lines the graph gets really close to. A little more work. You're going to draw a diagonal line from corner to corner. Like this. And then extend it. In fact, look at the slope. Up 5 over 2. Up 5 over 2. Extend this out. Extend it out. Okay, I'll zoom that out a little so you can see it. And now do it the other way. Box to box, corner to corner. It's a dashed line. Goes all the way out. All the way out. I know it seems like a little more work. These are the asymptotes. Asymptotes. I may even say, what are the equations of the asymptotes? You would say, well, y equals, what was the slope? Slope up 5 over 2. Up 5 over 2x. But wait, we also did one that went down 5 over 2. So put plus or minus. These are the equations of the asymptotes. But wait a minute, where is the hyperbola? Where is it? Let's draw it in. This guy starts with x. So because he starts with x, he's going to open like this. Okay? He's going to open in the x directions. So we go to this dot. Don't touch the center. Go to the dot. This dot right here and right here. In other words, pick the ones on the x-axis because it's an x. It's an x. Go to the x-axis. Now you're going to draw. Why did I do this? The asymptote, remember, that's a line you get close to, but you can't touch this. So go MC Hammer style. Dun, 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 dun. Draw it here. Don't go in. Draw and then curve. And then you follow the straight line. Then you go down here, curve, follow the straight line. Same here. Go to this one. Draw to the asymptote. Curve it just a little bit. Draw a straight line. Don't bend it away. Asymptote means you get close to the line. We put the line there so you get close to it. I will mark you wrong if you go, wee. No, that's not right. Or if you go like, wee, and curve it back. No, 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 don't do that. That's it. You're done. So I drew a box to find the corners to create the asymptote line so I know exactly how to curve it. Because sometimes your hyperbola will come out really narrow. Sometimes it's a little wider. Sometimes it's really wide. It can come out different ways. Okay? And if this started with y first, we would have been in the y direction. Okay, so there it is. We'll try another one. I'll show you one done from the. Okay, so here we go. We got y squared minus x squared. So how did they get the box? Okay, the y. Oh, this is under the y. Y is first. Y is first. Okay, but under the y, what squared is 4? 2. 2 squared. So notice from the center, they went up 2 and down 2 because the y is a 2. Now the x is a 3. So be careful. X is over here now. So they went over 3 and 3. They didn't put the dots, but some people put the dots to help them see on the graph paper. Draw the box. So there's a 2 in the y and 3. 2 and 3. They drew the box. They drew the diagonal lines. And then the next picture. And if I said, what's the equation of the asymptote? You'd say up 2 over 3x. Okay. And in fact, they do that right down here. Up 2 over 3x. Don't worry about the a and b or b and a. Just think, you know, change in y over change in x. And then they drew this in. How come they didn't draw it over here? Because y is first. So they go, let's go to the y dots. Go up and down in the y direction, then draw towards the asymptote. Okay, and all this other stuff's invisible. You wouldn't actually see it in reality. Ta-da! That's pretty easy. Let's check out another one. Oh, and here's one of those ones where you're like, why is there a 36? What did you do? Well, let's divide by 36. 4 goes into 36, 9. 9 goes into 36, 4. Now you can do it. That's the fastest you get. Okay, let's look at one that got moved over. Look at this guy. What do we got? Here's our equation. Oh, 2, 3. Why is it at 2, 3? X minus 2, y minus 3. That's the center. There's a minus. That's a hyperbola. If that was a plus, we would make an ellipse. Okay, the x goes 4 squared. So notice they went 1, 2, 3, 4. They went 1, 2, 3, 4. 1, 2, 3, 4. Get something a little better to point with. So the x went 4. Make sure you see x. Y goes 3 squared. 1, 2, 3. 1, 2, 3. Drew a box. Drew the diagonal lines. X is first. So go to the edge of the box. I see some people try to go in here. No, no, no. Then why did you draw a box? Don't go inside the box. Remember, think outside the box. Don't go in the danger zone. Remember, if you drew an ellipse, be like this. But you're doing the opposite. It's like you turned them inside out. You go to the outsides. The ellipse stays in the middle. The hyperbola goes outward. So you go here and then just curve towards a line. These are the vertices. It's kind of hard to read them off here, but if you do on graph paper, you could say, okay, oh, I could read it, 6, 3, negative 2, 3. And you could find the focus points, but I'm not going to require you. But where would the focus be? A focus is always inside. It's where all the energy focuses to. Like what if you look at my pictures of the parabola or a satellite dish, that's DirecTV satellite dishes. Everything focuses here. It's always inside the curve. The focus is over here somewhere. Not over here. Where does the energy focus? Inside the bowl, hyperbola. And how would you find it? Pythagorean theorem. C squared is a squared. And actually this time, remember it was minus? This time it's plus. It's kind of funny. If a hyperbola has a minus equation, but the focus is at a squared plus b squared. Well, in the ellipse that had a plus, you did a minus. But like I said, I'm not going to have you do the focus because I don't want to get too confused. Down here, they do some stuff to find the focus. Instead, it's 5. So then they drew it at 5. Okay, so that's it. There's all types of cool things. Here's a plane making a sonic boom. It's a hyperbola when it hits the ground. Remember, a cone, it's a flat surface, hyperbola shape. Okay, so you get to try some of the work. And let me just try one backwards with you. Can you tell me the equation of that? And I'm not going to try to do the word problems with this through distance line. Let's see. Okay, it's a hyperbola. So let's see. I know I have, wait, is this guy going to start with x or y? Does it open in the x direction or the y direction? Well, these are on the x-axis. It's shooting on the x direction. So we're going to put x first. X something squared minus something squared, boom, boom, equals 1. Okay, where's the center? Right here. The center is at -1, -2. -1, -2. Okay, the center, I'm going to write it here. Center is -1, -2. I'm sorry, you can't read that. Okay. -1, -2, so we're going to fill these in. The center is at -1, so we'll put x less 1. And this is -2, so we'll put +2. It's always opposite. And I have the x first because this guy's in the x direction. If this book had written the problem like that, I'd have to put the y first because it's a y hyperbola. So it matters. Okay, now let's find how far is it going in the x direction. It looks like it goes 1, 2, 1, 2. So we're going to put 2 squared, which is 4. How far does it go in the y direction? 1, 2. Oh, it's the same. 1, 2. 2 squared is 4. Ta-da! That's it. If you had to find the focus points, you would go a squared plus b squared, and you would go 4 plus 4. C squared is 8. Whoops, zoom out there. And you'd go, okay, the square root of that, radical 8, which is 2 radical 2. And you would go a distance of 2 radical 2, which is, you could put that in your calculator to get your decimal. It's like 2 point something, right? And you would go 1, 2, and a little bit more. You'd be right in there. Okay, so there you go. Try the work, have fun, look at the book examples, look at my video, look at the pictures. Okay, and then homework, do the homework for 9-1 and 9-2 that I assigned, submit a photo, and you got credit. You get 2 days to do this.